In the last lesson, we were discussing this, the comparison basically in the chemical equations. In Haber process, the pressure is high, very high, but in contact process, the pressure is low. And we were reading this, again I read, low pressure is feasible because the yield at dynamic equilibrium is appropriate, though increase in pressure increases the rate of reaction, but also increases the cost of production and maintenance. So the process becomes uneconomical. People say the process becomes uneconomical. And this is the diagram, somewhat diagram, you can look this. This is a combustion chamber where you are combusting gases, sulfur, you're burning sulfur. Then it is pushed into chamber to remove impurities. Then this is catalyst chamber. The catalyst chamber, catalyst is vanadium 5 oxide. These are the participation. And then it is pushed into another chamber, that is where concentrated sulfuric acid is showered to produce oleum. And then water is added to get H2SO4. So this is the reason, this is the equation given. Is it clear up to this point? Is it clear?
Yeah.
Now, there is also another improvement in this. If you look at the diagram, this is actually, this is a catalyst chamber. You can say this catalyst chamber is divided into multiple portions like this, and so on. When apart from the mixture, like SO2, O2 reacts, a reaction is exo. You can look, this is exo. Heat is produced. And that heat that is produced, it may raise the temperature above the stated range, that is 450 to 600 degrees centigrade. And what would be the impact of this? It will drift the reaction backward. It means due to the reaction, the extra heat produced, we drain out. We drain out by special ways, by particular ways. You drain out, you cool down the mixture, and push into the next one. Over here, more reactants which were still in unreacted form, they react together, and again heat is produced and remove extra heat. After cooling down the mixture, you push into another chamber, and in the same way we go on proceeding ahead. What will be the benefit of this? To removing extra heat. This extra heat which we remove, we use this extra heat to operate boilers. This is the boiler steamer. Boilers we run boilers due to the extra heat removed. And second is, it will prevent the backward reaction. This is the, you can say, improvement in the reaction, in the chemical process. No. Catalyst chamber is partition, means divided, before pushing the reaction mixture into next partition. The extra heat is removed to cool down the mixture, so the reaction prevent from moving backward due to excess heat. Is it clear?
Yeah.
Now, and extra heat, we make use of extra heat to operate boilers. We make use extra removed heat to operate boilers. This is boilers. Catalyst vanadium 5 oxide. This is V2O5. This is V2O5. This is, and then concentrated sulfuric acid is showered into SO3 to make oleum, and this is S2O7. Then H2 is added into oleum to produce H2SO4, and this is, you get H2SO4. And this is the way. Over here, one more question is raised. You may make H2SO4 by reacting SO3 with H2O. Now please look carefully. SO3, if you react SO3 with H2O, you get H2SO4. But we don't practice this to mix SO3 with H2O. Rather, we react SO3 with concentrated H2SO4 to get oleum. Then oleum is changed into H2SO4. Can you tell me the answer?
I don't understand the question.
Actually, like I write this equation. If you look this equation, this is the equation. You can look this. Can you read this equation?
Yeah.
Can you read? SO3.
SO3 plus H2SO4 goes to H2S2O3?
7. O7.
Oh, 7.
This is 7. Actually, this is. If you react SO3 with H2O, you get H2SO4. But we don't practice this. SO3, we don't react SO3 with H2O to get H2SO4. Why? Now please look. The reaction of SO3 with H2O is highly exothermic. It is highly exothermic. It is highly exothermic. And due to the heat liberated, H2SO4 turn into small droplets that are very difficult to collect. They are not difficult. They are very difficult to collect. And solutions start boiling. And that's why it is not recommended to make SO3 react with water. So this is the justification. H2O is not added into SO3 as highly exothermic reaction actor. This is more fumes basically, and vapors form. This is basically large fume, more fumes. This is more fumes and vapors form. The solutions start boiling, and or this is no need. So not added. This is not added. And water is not added. That's why. And H2SO4 is difficult to collect. This is. Is it clear?
Yeah.
So this is the justification. Next is Bronsted-Lowry acid-base theory or concept, you say. Bronsted-Lowry acid-base concept. Now look, please. This theory states acids are proton donors while bases are proton acceptors. Proton, you can say, if I say H plus is proton, do you agree?
Yes, yes.
Proton. Because H plus means H plus has 0 electron, proton is 1, and neutron is 0. 1 minus 1, it is 0. It means H plus consists of only 1 proton. That's why you can say H plus is proton. So in terms of proton, this theory states acids are proton donors, means H plus, while bases are proton acceptors. H plus contain only 1 proton. Example, you can look ethanoic acid in water. Can you see the equation?
Yes.
This is ethanoic acid and the water, and from here OH bond breaks and it will change into ethanoiodine, and H plus that is released by ethanoic acid, O accept H plus, it will change into H3O plus. This is H3O plus. This is H3O plus. And you can say this is H plus. And it is oxonium ion. It is oxonium ion. Achha. According to the definition, CH3COOH is proton donor with respect to forward sign, and H2O is proton acceptor. When the forward reaction occurs, this is Bronsted-Lowry acid, and that is Bronsted-Lowry base. For backward reaction, H3O plus 1. It is proton donor, and CH3CO minus is proton acceptor. This gives H plus and it receives H plus. And this is base and this is acid. Bronsted-Lowry base and Bronsted-Lowry acid. This is. So now I have shown CH3COOH plus H2O, CH3CO minus plus H3O plus. This is Bronsted-Lowry acid. This is Bronsted-Lowry base, and CH3CO minus, it is Bronsted-Lowry base, and this is Bronsted-Lowry acid for backward. Now it will pair up. Bronsted-Lowry acid, or you can say acid 1, base 2, base acid 2. On the reactant side, you can look, this is ethanoic acid. When it gives H plus, it becomes base. That's why it is called conjugate acid base pair. If I write this on the right side, this is CH3 H2O. This is reversible. OH bond breaks. It becomes H3O plus. According to definition, this gives H plus CH3COOH. It is called Bronsted-Lowry acid. This is Bronsted-Lowry base. Why? Because it accepts H plus and change into this. For backward reaction, this is Bronsted-Lowry base. This is Bronsted-Lowry acid. And it will pair up. Acid of left side become base on right side. Base of left side becomes acid on the right side. And they are called conjugate acid base pair. They are conjugate acid base pair. Means CH3COOH is conjugate acid and CH3CO minus is base. So they are pair, conjugate acid base pair. H2O is base, H3O plus is acid. So this is conjugate acid base pair. Yes, sir, is it clear or not? Is it clear?
I think so.
Achha, now I give you example. You try to do NH3 into water. Write equation and identify Bronsted-Lowry acid base for both sides, forward and backward side. You can do over here. Can you do? NH3 into water. You are adding NH3 into water. You have to write equation to show acid base pair.
Is that?
No.
No. Uh,
Actually, I explain. Look, please.
wait, is it?
No. This is. Look, please. NH3. You remove this.
Yeah.
No, this is wrong. You please raise. Look, please. NH3. If you look NH3, this is NH3. NH3. Plus H2O. This is reversible. Water. When you add NH3 into water, you get alkaline solution, not acidic solution. OH minus are produced. H plus from water. H plus from water. This is lone pair. This H is coming from H2O. It forms NH4 plus 1. It is ammonium ion. It is ammonium ion. And OH minus sign gets free. This is NH3 changed into NH4 plus 1. According to definition, NH3 accepting H plus, this is Bronsted-Lowry base. H2O is changing into OH minus on the right side. It means it gives out H plus. The Bronsted-Lowry acid. For backward reaction, NH4 plus 1, it is acid, OH minus is the base. So this is Bronsted-Lowry acid, and this is Bronsted-Lowry base. Now you pair up. NH3, which was base on the left side, on the right side, it becomes acidic. So this is called conjugate. Conjugate means they are linking together. They are linking together. They are joined together, basically. They are being derived from each other. They are being derived from each other. And H2O is changing into OH minus. And likewise, both species are being derived from each other. That's why H2O, OH minus, they are conjugate acid-base pair. Conjugate means to be linked, to be joined, to be derived from each other. To conjugate basically conjugate to be joined, linked, are you can say derived from each other. Issue. This is about pairing. No, please tell me, is it clear or not?
Yeah.
So this is conjugate acid base pair. Now I show you. Please look, this is what I have shown you on the right side. This is all written, and this is plus sign basically. This is omitted over here, and this is plus basically, and this is minus basically, and it's labeled below. This is it clear or not? Now,
Yeah.
Now, next is very small definitions that we usually come across. Strong acids. Strong acid, they are fully dissociated, or you can say ionized, to form H plus ion with maximum concentration, like H2SO4, HNO3, HCl, like this. Weak acid. They are partially dissociated to form H plus ion, like organic acid. That is organic, like ethanoic acid, partially ionized. That's why you use reversible sign. This is reversible sign you use. Or partially dissociated. Then strong base, they are fully dissociated from, are fully, you can say, dissolved. Form OH minus sign with maximum concentration, or you can say dissolved fully. To produce maximum OH minus concentration like this. Now, weak base, they are partially dissociated to form OH minus line. Partially dissociated. Like weak base, partially dissociated to form OH minus ion, like calcium hydroxide. And it is written, and this is reversible basically. Reversible. This is reversible sign, Ca2 plus 2OH minus. It is slightly dissociated, or you can say dissolved slightly. And there is a point below. Conjugate bases of strong acids. They are weak bases. Conjugate bases means? Conjugate bases means NO3 minus. This is conjugate base of HNO3. Being negative ion, it has the capability to accept H plus, but it is weaker. It is weaker. Basically, like HCl. This is strong acid, but it's dissociated Cl minus. It is weak base. This weak base means NO3 minus, HCl minus, they are feeble, they are weaker in accepting H plus. Likewise, H2SO4, H plus SO4 2 minus. 9. This SO4 minus is a weak base. Weak conjugate base of H2SO4. So this is the another information. The negative ion, which are dissociated from strong acids, they are conjugate bases, and they are weak bases basically. So this is all about for today's lesson, and Alhamdulillah, we have covered. This is part basically 10, and most of the part 11.2. Some part of 11.2. And if you have any question, you can ask right now. Do we have question?
No.
Achha, all right. You go through this. Okay, you go through this.